Wow, that sounds bright. Welcome back. As a lot of you have pointed out, the location of that wheel is maybe not quite, front to back where it should be. It should be moved a bit more this way. So I'm going to facilitate that and the mounting of a secondary gear increaser. It's not really a reduction. So follow along. First thing I have to do is break down what I have here, because it's not quite going to work for what I'm doing, and it's a pain in the butt to switch the wheel in and out if I need to do any maintenance, because this backboard here is just in the way. So I need to increase the length of those stretchers there and move this backboard further back. First thing I do before doing any sort of maintenance or adjustments on the wheel is I open the trap door, and that shuts off the water. Now, a lot of people have mentioned that inserting this additional block on the front there that you can barely see wasn't really understood why I had done that. And the reason for that was to make it so that when I do these sort of adjustments, back and forth ABA testing between different scenarios or whatever, that the pond doesn't take a lot of time to adjust to the new flow restriction of this long flume with a restrictor at the end. Because the water sees less resistance if it's dumping straight into the hole there, compared to if it's running the whole length of this flume and down through that restriction at the end. It's been kind of cold here. There's ice from the splashes forming on the sides. Pardon my butt shot. Yeah, this is what I was talking about. There she goes. So now I have to go to the basement and mount this on some rails with sprockets and half shafts or jack shafts, one of the two. Now that I have the water wheel off, and I've never videotaped this, but I've done it a few times, but never in the winter, I'm going to record how many gallons per minute are flowing here. With gallons per second or whatever, I have a, hope you can read that, 5-gallon bucket, and I'll stick it under here once the water's turned on. And you've probably been wondering what this stick is for. Well, that's so I can shut that trap door and turn on the water. I can tell this isn't quite up to speed yet. The stream is not as deep as it was before. So I'm going to let it equalize a little bit before I take a gallon per minute reading, like an official one. But I guess I can take one now. It's like a bicep curl. 1 gallon is 8 pounds. 5 of them is going to be 40 pounds, and I can't quite curl 40 pounds because I don't work out nearly as much as I should, or like at all for the past 2 years. Well, I'm going to go down to the basement and work on the water wheel, and we'll come back and do this in a few hours just to make sure it hasn't like changed significantly. I'm going to set up the water wheel on these sawhorses, but first I need to cut some risers because there's, these are a bit too wide to fit that bearing. The bearing would, well, the water wheel would hit on one side and then the sprocket would hit on the other. So I'm going to make a riser to make the sprocket ride over top of this, and the wheel will fit between these just fine. So here's my sawhorses, and these will go on here, and I just have to screw them in. Now, I'm of the opinion that an impact driver is slower than this drill. If you want a video on that, a race between a drill driver and an impact driver, let me know in the comments. If you're ever wanting to get mad at something, let it be gravity. Damn it, gravity! Of course, I'm just a klutz. That doesn't help. Yeah, pretty much exactly like that. Except the wheel's hitting, the bolts are hitting the sawhorse. So, there we go. Oh, now those bolts are hitting too far. Now you see why I had to add these risers. Also, there's a pretty good breeze coming off of it. If only there was something that was like infinitely adjustable and cheap and available to everybody in pretty much all parts of the world. What could that be? I don't know. Unistrut. So the cool thing about this is it's, you know, infinitely adjustable. The plan for this is I'll mount the bearings and then the sprocket half shaft and then the motor. And then it can all be adjusted for chain tension. And then this will stand vertically on top of those cross supports that are under the flume. And I could also very easily move this forward and back, up and down. Yeah, so adjustability. Now I just have to cut this into a proportion that is suitable for the lengths of chain that I have and the sprockets. Now I can sort of install this, but not really. I have to add the T-nuts and whatnot to these. Now I have to install these, the T-nuts, and then galvanized bolt and washer. This is all 3/8 hardware. One might be asking why I'm using size 35 chain, and that's because I got a lot of offcuts from one of my old jobs. This is the one that I had used in the last major video, not the last one, 2 major videos ago, right after I had installed it, testing it out to see how much voltage it made. And this worked okay, you know, it kept jumping off. And I think it kept jumping off because the sprocket here, come on, there we go. The sprocket here, it has a sharp edge. So I'm gonna have to grind that off. You know, this side is fine. This side has a nice bevel, but this side is just, you know, it's punched. Anyways, I don't have a chain brake, but I have a bunch of the universal links or whatever, whatever they're called. And so I'm gonna find a selection or a combination of these that's the right length to thread around here, you know, extend it past the wheel and above the flume up to about here. Get perspective up to about here, so it's out of the way of the flume. So I'll put those together. And then after I do that, I have over here in my box of goodies more bearings and a shaft and another sprocket and a few other sprockets, whatever, for the motor and whatnot. And all those will get mounted on here too. That's the first stage. A lot of comments in my previous assembly power video was switch out the sprocket size. Well, this is the largest number 35 tooth count chain or sprocket I could get, which is like 72 tooth. And then this is an 11 tooth. And I think they make a 10 tooth, but the problem is that when you get really small sprockets, they get really clunky. And then this guy, I sanded down the back face of it, the back face of the teeth a little bit, and it's still kind of clunking on its own too. Part of the problem is that this chain, it goes crooked. I installed the last sprocket, and I'm trying to keep it somewhat close to the bearing so that when I get up to where I'm going to mount the motor, it doesn't stick out as far. And this sprocket's got a little bit of a tight or a sharp edge on it too, so I might have to sand that down more. These are actually go-kart sprockets. Maybe a better machine sprocket would be, you know, smoother or more accurate. I don't know. And you can see it's kind of catching there. So now I'm going to make a big board here to mount the motor, and I'm going to use 2 more of those T-nuts to secure it here. And that should keep all of this in parallel, because right now with these swivel bearings, these aren't held rigid and parallel, and the board will just help with that. I mounted this block here just with 2 bolts, and I forgot all my big drill bits at my project house, you know, our new house that we're building, which has like all the wide spade bits where I could have countersunk this, but instead I just cut a rabbet, because I have the table saw, and the rabbet cut would be a lot easier to lower it than trying to do anything else with the drill bits that I have here. And then I clamped the motor just in place temporarily, and I have it hooked up to my voltmeter here. And these are really cool. These are Wago, I forget how they're pronounced. It's just a reusable clip, and I'm just sticking the voltmeter into the clip and snapping it shut, and that secures it nicely. Now I forget the equivalent ratio that this will be, and I'll put that in the screen now, right here, and I can give it a spin and we'll see how many volts we get, and I'll also tell you approximately how much resistance there, you know, it feels like. If you'll recall, last time I got 6 volts. And yeah, let's put it on the 200 volt DC and give the wheel a spin. It's a little bit, and a little bit faster. So I'm pretty proud of that. You know, we're getting 25 volts. I'm only going to be hooking this up to a 12 volt battery, and my charge controller can take, I think, up to like, well, a lot higher voltage than 25. And I hope it can reduce it down to a 12 volt lead acid battery, which is like 14.3 or 14.5 volts when charging. So, and even when I go really slow here, I'll show you how many volts I'm getting. 3 volts. That's enough to light up an LED. There's 5 volts, that's USB charging. 7 point something, that's a 2S lithium battery. And that's about how fast it'll have to go for minimum lead acid charging voltage. You know, somewhere in there, which is totally doable, I feel. And there's not a whole lot of resistance. And I think the wheel can overcome that. Let me use my pinky here and see how much resistance there is. Not much. Oh, another comment here. Some of these, remember when I used silicone carney to install these? Well, the caulk didn't really hold up that well. So I might have to reinforce these with some L blocks or something. Not sure exactly. Just for fun, I'm going to spin it as fast as I can by hand and see how high of a voltage we can get. Spin my microphone around so you can hear it. Well, darn, 60 some volts. I'd say that's a success. My brother and I were discussing my YouTube channel, and we decided that more videos that aren't as long is a better option. So that concludes the end of this video. In the next one, I'm going to install this out under the flume. Don't forget to subscribe. Hit that alarm button so that the next time I release the video, or the next video in this series, you get a notification. Also, thumbs up and leave a comment. See you around. But voltage, you say, isn't everything. How about current? So that's 2 amps at a speed that's roughly approximating like, well, let's see. That was about that speed, which is 7 or 8 volts. But I'm not concerned about that. You know, at that current and that voltage, the charge controller, which is an MPPT, will automatically draw as many amps as it can at the minimum voltage that it needs to maintain the battery. So it might draw only 1 amp at 12 volts, which would be a whole 12 watts. I know, right? Or yeah, I don't know. I don't know what it's going to draw. We'll see. All right. Last night I was up too late in the basement working on that stuff. So let's get a reading this morning.